Dear friends, in the last class, we came to know that conducting the practical on an aerofoil having the aspect ratio 5, we will determine CD and CL corresponding to the various angle of attack. And if we plot the curve CDCL versus angle of attack up to 7 degree, there is no change between the theoretical and as well as practical curve or measured curve. After 7 degree up to 10 degree, we obtain a peak point that is known as stall point. Corresponding angle is known as angle of attack. After that peak point is reached, the lift component will be reduced because of the separation point. If you take CD, there is no much variation up to even 10-12 degrees and then it increases. That is also because of the reason of separation at the trailing edge, because aerofoil is a streamlined body having only or predominant force is frictional drag, not the pressure drag. That's why CD drag coefficient will always remain constant up to that point. Now we can define further efficiency of an aerofoil is CL by CD, ratio of CL by CD. See, because of the lift component is much more than the drag component, efficiency of an aerofoil is found to be much more than any other bodies. That is the reason why helicopter and aeroplanes are navigated in space and they are flying at very high speeds because of more lift component which is produced or available when fluid is surrounding that body or object. Now, polar diagram. What is polar diagram? By Prandtl or as per Prandtl, he has combined all the three curves CL versus CD, CL versus angle of attack, CD versus angle of attack. These angle of attacks are taken on the parabolic curve itself, measured parabolic curve itself. Angle of attack, say 0 degree, minus 0 to 3, minus 3, minus 6, minus 9, 0, plus 3, plus 6, plus 9, plus 12, plus 15, etc. Angle of attack are taken on the parabolic curve or shown on the parabolic curve. CL is taken on y-axis. CL is taken on y-axis. CD is taken on x-axis. Also, CL by CD we know it is the efficiency. That also can be plotted together along with these two curves. That means combining the three curves, we will get a parabolic curve which is known as polar diagram. The dotted one, here you can see dotted one. This is also parabolic and it also resembles almost up to certain angle of attack and it remains same almost parallel to each other. Now you can see here alpha maximum lift, here that is the stall point, theoretical curve for CD for B squared upon A is equal to B by C is equal to 5. That means aspect ratio is 5. Aspect ratio is 5 as I said in the previous slide. CD is equal to CL square divided by pi BC. Values of angle of attack are shown on the, as I said, these are all angle of attack. These are all angle of attack, the values which are shown on the curve itself. Now, what is the use of this polar diagram? If you want to find out the efficiency. For example, I consider this point. If I want to know the efficiency of this point, I have to join this point to the origin and slope of this line joining the origin will give us the efficiency of that point. Clear? Now, if I want maximum efficiency of aerofoil, then it is the tangent drawn to the parabolic curve which joins, see, the tangent is drawn to the peak point and which joins the origin. The slope of this again, slope of this means slope of the tangent line joining to the origin is giving us maximum efficiency. Maximum efficiency. Whereas if you consider any point, you take this point, you take this point, join to origin, then slope of this line will give us efficiency at that point. Suppose if at that point I call it as A, then efficiency at A will be equal to the slope of the line joining the point and the origin. Whereas maximum efficiency maximum is equal to the slope of the tangent line joining the origin. Is it clear? So this is the major use of that. Apart from this, polar diagram is helpful to know the minimum drag, zero lift, and corresponding to the alpha, maximum lift or drag, because these are all plotted as values of angle of attack. It starts from 0, goes towards minus sign, minus 3, minus 6, minus 9 degrees, plus 3, plus 6, 9, 12, 15, etc. So up to around 15 degree angle of attack we can find the maximum lift. That is known as stall point. Corresponding angle itself is known as angle of attack. So this completes drag and lift. We'll continue in the next class. Wait, is not